Several times it happens to us to look up in the sky and focus at stars and wonder where those stars come from, what happens to them during their lifetime, and how do they die. In this video, we're going to talk about stellar evolution and how stars change with time. So, stellar evolution is the process by which a star changes over the course of time, depending on the mass of the star. Stars are created out of nebula, a vast cloud of dust and gas in space. The only force acting on particles is gravity. It pulls slowly gas and dust together into huge rotating balls as particles are pulled together and accelerated faster and faster. The gravitational potential energy is converted into kinetic energy. These balls are called protostars. Inside every newborn star, hydrogen atoms fused together to make helium. This process is called nuclear fusion, and it releases a huge amount of energy that powers every star. What happens to a star during the rest of its time depends on how massive it is. For average stars like our Sun is in a delicate balance between gravitational forces and thermal forces that try to make the star expand. At some point in the future, the hydrogen runs out, and then the gravitational forces are weakening and thermal forces are winning, causing the star to expand to be a red giant. Because it starts to use helium atoms and pushing them together to make oxygen and carbon. The expansion of red giants causes the star to cool, and then the thermal forces are weakening, and sooner or later the gravitational forces are winning. The core of red giant collapses into a white dwarf. For massive stars, the gravitational forces drives nuclear fusion, but it's using up hydrogen more quickly, and they are able to fuse heavier elements all the way up to iron. In this time, the star expands because he can't burn iron inside their core. The outer parts of the star are blasted off into space in a huge supernova and explosion, and it collapses into a neutron star, and if massive enough, the gravity is so strong, it becomes a black hole. Ultimately, a star is composed from all materials, which our Sun, Earth, and indeed ourselves were made. That's why we must know their evolution, because it's telling us where we came from.